Welcome to another Simply Diagnostics video. Thanks for watching.
Welcome to another Simply Diagnostics video. Today we're going to be looking at start and charge system using the picoscope. Just run through some basic fundamental checks that you can do. So we're using the 4425 scope. Channel A, we've got blue voltage, and channel B, we've got the 600 amps current clamp connections. Channel A onto the battery post. Channel B, 600 amp clamp onto the main battery cable. And what we're going to do first, I've already identified the fuse for fueling and ignition is that 10 amp there, so we're just going to pull that so I can crank it without it starting. I'm just going to do a basic relative compression test. Scope set up, we've got 2 channels set up. You see channel A, we've got on a 20 volt scale. Channel B, we've got on 600 amps clamp. And then we've got a trigger. We've got a trigger set up, a single trigger on channel B. So it'll start capturing once we crank the vehicle. So I'll leave you watching the scope while I go and crank the vehicle. So we can quickly see from there if we put add a measurement, channel A, we want minimum. Okay, that gives us the minimum voltage. So you can see on cranking it's dropping down to 8.278 volts. And then channel B, do a maximum. We see channel B, the maximum current draw from the starter motor, 774 amps. So a nice quick easy test there for starter. What we're going to look at now is the actual charging rate for the vehicle. So we'll extend the time base, we'll put it onto a 10-second time base. Start the scope running, and what I'll do now, I'll put the fuse back in so it'll actually start running. So the fuse is now back in. Fuse is back in. Why is that so noisy? So what we can see is that zoom, so all I've done there, I've activated my filtering, and we can also add a measurement for the maximum voltage. And we see maximum voltage 15.26. And what we can see is on cranking it dropped down to 9 volts. But then once the vehicle actually started running at this point here, it started charging very quickly. So let's have a look at some of the other checks we can do. Right, so just using a standard multimeter, I've pulled the fuse again. I've got battery support on this. You can see it's at 14.28 volts. The meter connections, I've just got, I'm on the main battery lead and the main ground, and all I'm going to do now, I'm going to hit the record function, and that should give me my min max. I'll crank the vehicle again. Then we go through. I'm in max now. Minimum was 12.44, maximum 14.69. So let's try it without battery support. We'll turn the battery support off. You'll see the surface, we'll just get rid of the surface charge as well. Right, so that's got rid of most of the surface charge now. We'll do the same thing again. Hit the record, that'll give us our min max, and we'll crank the vehicle. Minimum 11.23, so you can see the meter is not actually as accurate as the scope, whereas with the scope it was dropping down to 9 volts. The meter's not fast enough, and you'd be tempted to say that, you know, there was nothing wrong, but we can clearly see that I mean, it's a genuine battery on it. It's the original battery for the vehicle, so it's a 6-year-old battery. The scope clearly showed that it was dropping down to 8.5, 9 volts. I'm cranking, but the meter's not picking that up. Okay, now we'll have a look at another couple of simple tests that we can do. Right, so what I've got there now, what I've got rigged up, just seeing in shot, I've actually got a relay breakout box on the starter motor relay on pin 87 on the red lead, and then the blue lead is actually going, if I show you here now, the blue lead is actually down there on the starter side of the starter low tension connection. So what we're going to do now, we're going to do a volt drop test across that connector. So you can see the difference there is 100 millivolts. Let's see what happens when we crank it. Let's min max it as well. Let's try it again. So our maximum went over. Right, so if I plug it back in now, so I've actually plugged the connector back in. We try that again. So our max was 230 millivolts. So that's volt drop testing in its entirety. Really, there's nothing simple about all we've done there. Simulated an open circuit on the starter terminal. We've simulated an open circuit on the starter low tension wire. You can see on a good connection we got about 230 millivolts drop, and on a bad connection where it wasn't actually cranking, you saw it went out of range. And what we can also do with this We can actually measure the volt drop across 1387 if we suspect it might be the starter relay that's at fault. We can go onto pin 30, and then we can measure the volt drop across 1387. We'll record that. Quiet. You can see the volt drop across it, 0.03 of a volt across it, so the relay itself's good. So that's a dead easy way to check it, check volt drop across the two terminals. Right, what we can also do as well is we can check AC ripple and alternator performance. What I've actually got, I'm actually on the back, I'm on the main post of the alternator there with the red lead. I'm on ground there. So we'll start the vehicle and see how it charges. So you can see there, charging at 14.75 volts. Charging at 14.5. All we need to do now, what we want to do now is to see if there's any AC over the top of that. See how good the diode packs are. We've got 0.04 of an AC volt coming straight off the back of the alternator. We can also, with this, using this method, we can do a very quick volt drop test. All I need to do, put it back onto DC volts, and all I'm going to do is move the lead from the ground post to the main battery post. So it's now on the main battery post. And we can see there we've got 43 millivolts volt drop on the main cable. So the main cable going from alternator to battery is also okay. And what I'll do now, I'll quickly put the scope on it and we can have a look at the AC. So to look at the AC on it, going on to channel 8. That's looking at the DC, so it's currently charging about 14.5 volts. Go on to AC coupling. With this, we can also add another measurement if we go onto channel B. Actually, we'll just put it on 100 millivolts per amp. Just put it on 2 volts, and all I'm going to do is put a current clamp on the battery wire as well. So then there, I've put a current clamp on the battery negative. I'm actually looking at the charging rate now. What's actually going into the We had a measurement for that. Channel B, average. Okay. So that's 485 millivolts. So that'd be about 40 amps. Doing a quick bit of maths, about 40 amps. But we zoom in this is quite interesting. We zoom in this, you can actually see that the alternator is actually charging it's quite cyclical. So it's not just a steady output. You'd think it would just throw in a steady current out, when it's not. Actually, it's cyclical. So I hope you enjoyed this brief video. Start and charge. It's part one of a series. This will go in the basic electrical playlist. I hope you enjoyed it. I've deliberately left lots of gaps in it to promote you asking questions, get involved in the YouTube group, ask questions, various testing methods and stuff like that. So come in, join in the discussion and get your questions asked. Thanks for watching.
And thanks for watching the video. If you liked it, don't forget to leave us a thumbs up, hit that subscribe button. If you didn't like it, give us a thumbs down, put in the comment section below and let's get a conversation started. We've also got ways you can support the channel now. If you look in the links below, we've got Patreon, buymeacopy.com and a direct PayPal link. Thanks for watching and thanks for supporting the channel. You're awesome.